When factoring, the first thing I always look for is the greatest common factor. After that, we count how many terms. If we have 4 terms, then the method that we are going to use to factor that polynomial is a concept called grouping. Here's an example. If I have x cubed minus 7x squared plus 4x minus 28, I'm going to look for a greatest common factor first. And I notice that I have x's here, x's here, x's here, no x's there. A greatest common factor has to be common in all of the terms, not just some of them. I recognize that 7 times 4 is 28, but those don't have common factors as I can't take out a 7 out of a 4. And there's no greatest common factor when the number in front of your x cubed is a 1. So I know that I have no greatest common factor among these 4 terms. So that's when I use the concept called grouping. And what I'm going to do is I'm going to look at my first 2 terms and say, okay, if I just had these 2 terms, what's the greatest common factor there? I say, well, once again I have a 1 in front of the x cubed and the negative 7, so there's nothing common among a 1 between a 1 and a 7. But I have x's here and here. The greatest common factor with my variables is the smallest exponent. So I have an x squared that's common. If I pull out an x squared, what am I left with? Well, I took out 2 of the x's, I had 3, so I have 1 left over. I took out the 2 x's, so I'm left with the minus 7. Now I'm going to do the same idea with the second 2 terms. I'm going to group those 2 together and say, what's the greatest common factor between 4x and 28? The greatest common factor there is 4. Now it's a positive 4, and because I'm grouping 2 separate terms, I need to put that plus sign in to separate my terms, because I rewrote these 2 terms as the single term. Now I'm rewriting these 2 terms as a single term, taking out the greatest common factor of 4. If I take out a greatest common factor of 4, what am I left with? Well, taking the 4 out of here, I just have the x. 28 divided by 4 is 7. Nothing switched my sign. We're not done with this problem yet, because for a problem to be in factored form, your final answer has to be all multiplication. We have multiplication here, we have multiplication here, but they're being separated by addition. So we just simplified. We made 4 terms into 2 terms, but they're still terms. I need my final answer to be factors so that the problem is done completely. But what you might notice is look at those ugly parentheses. The x minus 7 in both of them is the same. So I can do exactly what we did at the end of the greatest common factor section. I can take out that common factor of x minus 7. So my next step is to pull out this common factor of x minus 7. What am I left with? Well, the first term, if I take out the x minus 7, I'm left with x squared. And in the second term, when I take out my x minus 7, I'm left with the plus 4. Now it's a quantity times another quantity, so I am done. This is factored form. Let's do another one. Here's another example. Once again, the first thing I always look for is a greatest common factor. I don't see one again. I see, though, that I have 1, 2, 3, 4 terms, so I'm going to use my factor by grouping. That means, once again, I'm going to group the first 2 terms and take out the common factor. The greatest common factor is, in this case, x squared. What am I left with when I pull out an x squared? Well, I had 3 x's, I pull out 2, so I'm left with 1. Had the 2 x's, I pulled them both out, so I'm just left with the plus 5. If there was no number in front of there, I'd be left with a plus 1. You always have to have a term, as something there as a placeholder. Now I'm going to do the same thing with my second two terms. But what I notice here is that both of the terms are negative. Now I know when I factor by grouping that this quantity is going to be the same in both of them. And the quantity here has two terms that are both positive. But I have two terms that are both negative. So to turn those negatives, switch the signs around, my greatest common factor of those two terms will be negative. So what's common among or between a -2 and a -10 would be a -2. So my greatest common factor of these two terms is going to be a -2. So I indicate that by using my subtraction. -2x divided by a -2, negative divided by a negative is a positive x. -10 divided by a -2 is once again a positive 5. Remember that you can always check this by redistributing. This is not a 2 that's being distributed in, as we learned from last week, it's a -2. All subtraction can be turned into adding a negative. Negative times x is a -2x, -2 times a positive 5 is my -10. So it checks out. Once again, now this quantity is the same in both of my terms. It will be. If it's not, you did something wrong. Okay, so now we can take it that next step and say, oh, what's common now? Keep going with your factoring and say, x plus 5 is what's common in both. So I'm going to pull that out and see what I'm left with. The first term I'm left with x squared. The second term I'm left with is -2. Can't go any further on that one, so we're all done. And that is how you do factoring with 4 terms. It's called factoring by grouping. Take your first 2 terms and your last 2 terms. Take out the greatest common factor, you'll see that you turned your 4 terms into 2 terms, and then those 2 terms will have this quantity that is identical. Pull that to the front. Remember, we only write that once. If they're not the same, you did something wrong. Okay? Pull that to the front and see what you have left over. That's in your second binomial to say what's left over. Once again, that's factoring by grouping when you have 4 terms.